Alright, let's take a look at this problem. Word break 1. Give a string S and a dictionary, given a string S and a dictionary of string word dict, and return true if S can be segmented into space-separated sequence of one or more dictionary words. So here this is true because you can have apple, you can have pen, and then you can have apple, and then when you concatenate those, you will basically have this. So, or like if you look at it in a different way to this problem, you just break word into uh, words in word dict. All right, so how do we do this? So I went over this conceptual overviews, and I saw that it is possible to do it with dynamic programming. So this is my first time implementing it, but the idea is like this. So if you're searching for LeetCode, first you create an array of false dynamic DP elements, and then you simply turn the first one into true, because you can like, if you don't have any words, then you can just form that, right? But later on, for every character here you have in your dictionary, you check if you can uh, like generate, or like if you can form that substring using words from word dictionary. So to form this, we basically want the last word. So to form, maybe like just to form LeetCode, we have to form lead. Okay, just a second. Okay, I'm back. So to form LeetCode, we basically have to form the code lead before, and to store those we will use DP, and in that DP we, yeah, like I said, like if you have like LeetCode a start, it should be true, and then you have false, 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 and then you just go on over this word and see if you can form it. Then when you can form it, you look at the previous index, and then if you can form that, if that's true and also the current one is true, just turn it to that, and you continue from there, and then you see that something in word dictionary similar to actually exactly in the word dictionary, and then you turn it to true, and at the end you'll turn it to true because this part is true, and then the previous last index is also true, and then you will have your result there. So maybe, yeah, maybe just turn these into. All right, so for this I'm going to create a helper function which will take the S word dictionary, and I won't need the DP, I can just create it here. So I'll have DP equal to the length of, actually false, it's false, yeah, it's just false, number of length of S plus 1 times, because we want to have the 0th one equal to true, because when it is empty it should be true, and we are always looking the previous one, so this should be we should have true for the base case. And then we simply want to go over this word, which is for every I in range, length of s. So we go over it for the first. So we just pick the first character, and from there we just increase the window. So for increase the window until the end, or we increase the window from z from I. Well, how do I have my? Let's see. Okay, so when we get to the end, so when we get there, we check until this point. So we will start for every j in range until I. Actually, this should be I plus 1. So I started with the first one, plus 1. Wait, let me think. It should start from 1 because we have our DP. So I will go over DP with that. And J should be, okay, so should be like that. So I is here and J is here. Like that. I is here, J is here from 0. Now what you want to do here is that you check if the previous, which is actually the if dp j and current I is equal to current word and current words in dictionary. We just have to, at that point, we just have to turn dp. What is the current word? Current word is from j to I, so s j to I plus 1 in dictionary, which is word dictionary. And here we turn I into true, and then we break here because we're just done with that part. I mean, we don't have to continue later on when I pointer comes to. Okay, for now, I guess I should start from this, but okay, maybe just go over this example. We come here from j to I plus 1, which is basically the 0 to L is not in word dictionary, so we increase j. It is I, so we don't go in, we increase I by 1, and then go like this, and it's not in there until I is at position T, and then we increase it. It is not in, increase it, it is not in the dictionary or dic, this part. Actually, let me see, I'm actually wrong. So I increase this to, oh no. So J0 I is 4. Okay. Right. I is actually 4, 5. Okay, I shouldn't have 1 there because I is always 1 ahead. Representing 1 more, like here. It is representing fifth element in the DP, but it's representing the fourth. Should represent the fourth character. So um, here we see that dpj, which is true. Now we check if I until 5, which is this part, is in dictionary. Yes, it is in dictionary. We turn this into true, and then what happens is that we just break from this and then increase I by 1, and then j starts from here, and then actually, yeah, it goes on like that. Is there a LeetCode C? No. And it goes on like that, goes on like that, and then we check if there is a LeetCode in our word dictionary. No. We just continue like this, and when we see that the pj is true, now we check if there's a code, if there is code in our dictionary, and we see that there is a code. Now we just go in and turn this to true, and then break. So this should work as this, and what happens here is that we have to return the dp -1 because we only care about the ending result. And here we simply return helper as word dict. Let's see if that works. Wait, actually. How do you do this? False length. Wait, it actually. Try that. Okay, so it works. Maybe try some the other cases also. All right, let's try this. All right, so what's the time complexity here? So this is O of n, and this is also O of n, which is the length of the string we are looking for. And also, is there anything else? No, this is just n squared. So the time complexity is O of n squared, and space is, of course, O of n because of this dp. All right, so that was it.